Hi students, we're back for another week of talking about how to analyze your data in SPSS, and so we're going to have a couple of recordings on this. This particular lecture is on how to use SPSS to analyze your survey results, and then the second lecture will be about how to use SPSS for your experimental results, okay, or experiment results. All right, so I'm going to take a spreadsheet that one of the students in a previous semester sent to me, and this was on a survey much like the one that I described when we were talking about research methods in terms of surveys. And I think that group I described had, let's see, adaptive and emotional planks in their survey. And this one is kind of like that, but not exactly like that. Let me open this up. All right, first, I'll show you how the group organized their data, okay? They had gender and dummy-coded the gender of the participant as 1 for women and 2 for men, okay? So 1 for girls and 2 for boys, okay? Because these were kids responding to their survey. In the second column, you'll see that they have age, all right? And they have dummy-coded the 9 and 10-year-olds as a 1, and then they've dummy-coded the 11 and 12-year-olds as a 2. And so they could split younger versus older children in this survey and look at their responses, okay? All right, I'll skip through the other things. These were other demographic items. And then we get to the survey itself. All right, let's look at this survey for a moment. It looks like question 1 had to do with adaptive behaviors of some kind. And then question 2 was on adaptive behaviors. And then they had a couple of other planks in their survey. Another plank was called protective factors, okay? I'm not sure what that meant, but we'll just use that as another label in their survey. And then they had something called risk factors. So it looks like they had 3 different factors in one survey versus the one that I talked about last time that had 2, right? It had adaptation and it had emotion. Well, this one has 3. It's adaptation, protection, and risk, okay? How many items did they have on the survey? Well, this is question 1. Let's scroll over and see. It looks like they had 39 questions on this survey, okay? Some of them are risk, some of them are adaptive, and some of them are protective, okay? All right, how do we organize? Now, this is in Excel, right? And I always encourage students to go ahead and set up your data in an Excel spreadsheet, and then you can transfer the data to SPSS. All right, so how do we do that? Let's see. We have gender, and I don't think we want to look at that maybe in our analysis, but maybe age is important, okay? Young children and older children. So I'm going to open up SPSS. Here it is right here. And usually in SPSS, we always go to variable view at the bottom, this tab that says variable view, and click on that first so we can name all of the variables that we have in the study. All right? So I'm just going to call this age. And then I'm going to go over here to this column that says values, okay? If you click in the cell, in the corner of this cell is a blue little button that I just clicked on. Did you see that? It really happened quickly, but if you go to the right of this cell, there's going to be a blue button, and you can click on that. And now, notice that I said age was dummy coded. In other words, there's just a value for one group and a value for another group, and they just decided that a 1 would mean younger kids and a 2 would mean older kids. Okay, so here I'm going to say 1 is younger children, and I'm going to click add. All right, you see how I did that? And then I'm going to make the value, the dummy code 2, be older children. Okay, and I'll click add for that. And now I've dummy coded age in SPSS. I'll click OK. All right, so there is that. That's age. Now what's the next variable I want to put in? Well, probably all of the questions, right? I'm going to go 1 adaptive, I guess. I'll just call it 1 adaptive for the question, 1 adaptive, and that'll be all in one continuous sort of name for that one. Oh, we can't use that. It'll have to be adaptive 1. Let me try that. Yeah, that worked. Okay. So we'll have to put the term first and then the number, the question number second. Question 2 is adaptive 2. All right, so I'll type that in. Adaptive, I spelled it wrong. Adaptive 2. All right. Notice there's no space between the word and the number. All right. The third one is a protective 3. Protective 3. Okay. And I wonder if I can do a split screen where it won't be so hard to move between what I'm typing in SPSS and what I'm seeing in Excel. So let me make this about half the screen, and then I'll make this one about half the screen where I can see what I'm typing in. Okay, so let me just move this around a bit. It's just a way to make it easier for me to understand what I'm looking at. Okay. All right. The fourth one is going to be risk 4. The fifth one is adaptive 5. Okay, and let me move over so I can see what's going on in Excel. I'll just sort of move this over and not lose track of where I am. All right, 6 is adaptive 6. 7 is risk 7. 8 is adaptive 8. 9 is risk 9. 10 is adaptive 10. 11 is adaptive 11. 12 is protective 12. Adaptive 13. Risk 14. Okay, and risk 15. Let me move over a bit more. All right, it's cold outside, so I have this jacket on, but it's warm in here, so let me remove this for a minute. Now, you know, you'd be smart if you were watching this video, this lecture on your phone, and then having SPSS up on your computer so you can kind of go along with me, well, at least to name the variables, okay? So you can get an idea of what's going on, all right? We have protection 16, protective 16. Oops, wait, I'm typing in the wrong spot. Sorry. That was in Excel. I want it here. Adaptive, 16. Risk is 17. Oh, wait. Did I move over? I didn't. Let me see what I'm doing here. See, sometimes we'll get mixed up if we don't watch what we're doing, okay? Protective is 17. Protective is 18. Protective is 19. Risk is 20. 21 is risk. 21. Protective, 22. Protective, 23. And now I'm just going to pause the video for a minute and go ahead and fill in the rest of these, and then I'll come back on and tell you what to do next, okay? Because I'm taking a lot of time entering all of these variable names. All right, now I've entered all of the names of all of these survey titles for each of these 39 items, okay? So I have risk 39 is the last one. So you can see I just have age up at the top, and then I have all of the survey items with what the group designated them as, okay? And now I'm ready to go to the data view here, and I'm going to enter the data that the students have. First, for age, I'm going to copy all the dummy codes for younger and older. Boy, they had a lot of participants in this one, didn't they? Looks like they had 200 and I can't tell, 233 participants. I'm going to copy that and paste it here, okay? Now, I'm going to grab all the survey items, the ratings on the survey items. So I'll go across, and I'm just going to highlight all 39 and go all the way down to the last row. Notice that every participant has a row here, right? All right, I'm going to copy that and paste it in SPSS. Now I can make SPSS big and make sure that all of the data copied or pasted correctly into this sheet, and it looks like it goes over to 39, and then we go down to 232. All right, that's something right. I think that's right anyway. Was it 232? Let me just go back to Excel and make sure. I'll pull over here, and it looks like, well, there's 233 rows here, but they have the variable names in the first row, so it is 232, okay? So they had 232 participants in this study. Now I can close out this Excel spreadsheet and just work in SPSS. Now what do we do? The first way to analyze a survey, and you can follow along. Of course, you don't have access to all these numbers, but you can sort of write these things down on your notes. I've entered the age groups. If you want to look at something else, that's okay. And then we have all the ratings on all of the items from their survey, okay? And every participant is arranged in one row here, so this was participant one's information going all the way across, okay? Now, how to analyze. The first thing we want to do is see if this survey was reliable, okay? Now remember last time I talked about validity. Does a survey measure what it's supposed to measure? Well, you can see that just by looking at the items. Do they measure adaptability? Do they measure protection? Do they measure risk? Okay? Those are things that you figure out in your groups, okay? And make sure they don't measure anything else. But now we're going to talk about reliability. How reliable are your items across all of the people who responded to your surveys? Okay, and we can get a number for that. It's called Cronbach's alpha. Okay, and you'll see that in the output here. I'm going to click on Analyze. Then we're doing a scale, so I'm going down to the scale, and I want to do a reliability analysis of the scale. So that's what I choose. I went to Analyze, Scale, Reliability Analysis. Okay. Now up pops this little form here. I'm going to leave age out of this because we're not looking at age in the reliability. We're only looking at the items that were on the survey. Notice I've only highlighted the survey items. I'm going to move those over into this box called Items. Okay? So you can see 1 through 39 are now in this middle box. Okay? And they're all there. All right, in your notes, the next step is going to be to click on Statistics. What kind of statistics do we want? Well, we want the descriptives, that means the mean and standard deviations for each item, for the entire scale, and for the scale if we deleted an item. Okay? That third one's important. You want to make sure you've clicked all of these boxes in descriptives 4. The other thing we want to have are the means and variances for the entire scale. Okay, so I've clicked those two things there. Okay, and now I'm just going to click Continue, and then very simply OK. All right, do you have all those steps? All right, make sure, go back to Statistics. I have the first 3 boxes checked and the second 2 boxes checked. Okay, then I clicked Continue. All right, in your notes, you click on OK. Okay, let's look at Cronbach's alpha for this scale with all 39 items. Okay, I see that the reliability of this scale with all 39 items is not good yet. And why do I say that? This number, 0.579, is lower than good reliability, which is 0.70 on a scale. All right? If you get 0.70 or higher, that means you have a good survey. Okay? And it's a reliable survey. You can see here, reliability is lower because it's below 0.70. Okay? So how do we fix this? Well, we have to go down to this table. It says item total statistics. Do you see that table there? Now, if we were to delete a certain item, we would get a better reliability than what we have now. The reliability right now is 0.579. I'm going to make some notes, okay? It's always good to make notes. I'll just go Notepad and see if I can open up one of those. I'm going to make some notes here just on my statistics. Okay, now, initial reliability with all 39 items is alpha equals 0.579. Why is this text so big. I just want to have smaller text so I can see it all in one shot. Oh, it's way up to 48 here. Let's move it down to about 12 so I can see what's going on. Okay. So now I've said initial reliability with all 39 of the survey items is 0.579. Okay. Now if I go down to this item or item total statistics table, I look in the right-hand column, going down this column. I want to find the highest reliability I can get if we delete one of the items. Okay, do you understand what I'm saying? And so, if I go down, I see 0.610 right here. If we delete item 25, which is probably not a good, reliable item, we can increase the overall scale reliability to 0.610. Is there a number that's bigger than that in this list? It looks like that's the highest number, right? Okay, so we're going to delete risk 25. I'll put that in my notes. Deleted risk 25. I'm going to close my output for a moment. I'm going to go through the same steps. I'll find risk 25. It's right here. And I'm going to move it out of our analysis, okay? And then I'm going to click OK. Notice that our Cronbox alpha has increased to 0.610. Okay, reliability in my notes with 38 items is alpha equals 0.610. It's still not to 0.7 yet, is it? Okay. So we're going to have to go down again to our table. This is the item total statistics. We're going to go down this right-hand column and see which number is highest if we delete that item. It looks like it was 0.642. Is that what you're seeing? 0.642 seems to be the biggest number here, all right? So let's delete, and that is another risk question, isn't it? Risk 26. In my notes, I'm going to say we deleted risk 26, and I'm going to close my output again, and I'm going to delete risk 26 in my next analysis. Okay, so let's find risk 26. Remove it. Okay. Now this gets rather fast after a while. After you get the hang of this, you can just kind of knock out the next one and knock out the next one and click OK. And here we have 0.642. Okay. So now reliability with 37 items is alpha equals 0.642. We're still not at 0.7 yet. Okay. You know, it's possible that you may find that on your surveys you might have really low reliability and have to remove quite a few items to hit 0.70. Okay. It's very possible. But it looks like the risk questions on the scale were not very reliable. Okay. Not contributing to the over-reliability of the whole survey. All right. Now let's go down to our same table, enter our item total statistics. We want to get to 0.7. What is the highest number? Here's 0.670, here's 0.676. Looks like 0.676 is the best one, okay? Oddly enough, it's another risk item. Risk 20. Okay? Deleted risk 20. All right, now we're going to close out our output again and do the same thing. Analyze, scale, reliability analysis, and what's the one I'm removing? I forgot. It's risk 20, okay? Risk 20, and it's good I'm taking notes, right? Because I would have forgotten that. I moved risk 20 out. I'll click OK again. Our reliability now is 0.676. It's getting exciting, right? Reliability with 36 items is alpha equals 0.676. Okay. We're still not at 0.70. Let's go down to this table, item total statistics. Is there a number? Oh, it looks like we can get to 0.706 here. 0.702, 0.706. And again, we have a risk item, and it's risk 15. Okay? I'm going to say removed or deleted risk 15 in my notes. This should bring us to the desired reliability for the survey. I'm going to click Analyze, Scale, Reliability Analysis. The one I'm removing, according to my notes, is risk 15. Let's find that one. We move it out, and let's do this one more time. It looks like Cronbach's alpha is 0.706. Okay? So, reliability with 35 items is alpha equals 0.706, which is acceptable. How do I know that 0.70 is acceptable? I'll have to go and find a research paper that says that reliability of 0.70 is sufficient for a survey. Okay? How do I find that? I go probably to Google Scholar and look up a paper that says that. Okay? And then I can quote in my results section, or cite in my results section, that person who said that 0.70 is the cutoff for good reliability of a scale. Now, what do we have? We have 35 items left. The students originally had 39 items, okay? So we only had to remove 4 items, but what did I say last time? You need about 30 items on a survey to make sure you have enough items left after you do a reliability analysis like this to be able to function, right? Okay, how do I write this up as a results section? Let's just go to Word, and you're watching this on your phone, but make good notes. Usually we'll have a centered and bold word in 12-point font that says results. All right, and what I would say is in a indented paragraph, reliability of the whatever scale this is, I think it's COVID-19 adaptability, risk, and protective factors scale. We just come up with a name for our survey, right? I guess we'll call it a survey. Was assessed. Okay. So you're going to come up with some kind of a name for your survey, whatever it may be, okay? Make sure we double space throughout the results section. All right, initial reliability of the 39 item scale was poor at, and now I pull up my notes, what was the initial reliability? It was 0.579. Now I'm going to insert a symbol for alpha. Let's see if I can find one. This is alpha right here, Mr. Alpha, okay? Is alpha equals 0.579. After how many did we remove? After 1, 2, 3, 4 items, after 4 risk items, were removed, overall reliability of the, I'm not spelling well today, reliability of the scale with 35, was it 35? Go back to my notes. Yeah, 35 items was acceptable at 0.70, what was it, 6, I think, right? 706, yeah, okay. Now, I can't really say this until I look up that paper that says that, reliability of scales needs to be at 0.70. I guess I'm just going to go to Google Scholar and open that up, and I'm going to say scale reliability 0.70. How's that? And let's just see if there's a paper that tells me that is okay. Is it here? Do you see it yet? Good reliability. Okay. Let me pull this up because it looks like it's here. Well, here's another one here, I guess. Let me just pull this one up because it looks like it's more straightforward. Reliability of the scale. Can't be downloaded securely. Oh, man. I'm going to say keep it and let's open it up. All right, let me make this bigger. Zoom. All right, oh, not that much, just enough where we can see it. Okay, I want to see 0.70 somewhere mentioned here. Give me a minute to find it. Do we see 0.70 yet? All right, I'll tell you what, I'm going to pause this lecture just for a minute so I can find the proper area where it says that. All right, students, I have found a paper that actually has this 0.70 cutoff in it. Okay, this one is called a meta-analysis of Cronbach's coefficient alpha, which we're getting for this survey. Okay, now this one says Nunnally, 1967-1978, is the most widely referenced recommendation for a reliable coefficient. Okay? All right, and so that is the most cited, I guess, paper on this coefficient alpha. What I'm going to do is pull up my Word document and make it just a bit smaller so I can get a citation in my results section, okay? After 4 risk items were removed, overall reliability of the scale with 35 items was acceptable at 0.706. Okay, coefficient alpha is generally considered good if the scale reliability is 0.70 or greater. And now I can cite my source. So it's Nunnally, and that is 1967 and 1978. So there's 2 papers that say this. Now I'm not going to get rid of this just yet because I'm going to go down now to the references in this paper, because I'll need those for my own references section. And then I'm going to type in those references in my reference items. Okay, so Nunnally, here it is. This is 1967, this is 1968. Let me pull this down just a bit so I can work with my Word document here. All right, and here. So just down in my references section, you've already got one for your paper because you've already written a intro section and you have several references, right? But you're just going to add these 2 Nunnally papers to your reference section. All right. Now it's Nunnally, and his name is J.C. The year is 1967. It's a book, Psychometric Theory, first edition, New York, McGraw-Hill. Okay, those are the publishers, McGraw-Hill. Now I'm going to go back, and for a book, what you're going to do is italicize the name of the book. I forgot to put a in parentheses mark here, okay? And the period should come after the parentheses. All right, we have the first item for Nunnally. The second one is Nunnally, J.C., 1978. This is yet another book. Oh, well, it's the same book, only a second edition. Do I really need that? You know? So I'm going to delete that. I'm going to go back up to my results section, and I will just say 1967, okay? And leave it at that, okay? So now I have a reference item for Nunnally's paper here, and of course, if I were really picky, I would make sure that this paper is saying the right information by going back to the original source, which is Nunnally 1967, and finding that book in the library, okay? Or at least online to make sure that's what he said. But I know that, you know, from my own work on writing up scale results. Okay. Do I have everything now about reliability of the survey itself? And I think I do. I said initial reliability of the 39 item scale was poor at alpha equals 0.579. I guess I should say at Cronbach alpha, right? After 4 risk items were removed, overall reliability of the scale with 35 items was acceptable at 0.706. I should say alpha equals, right? Let me copy this stuff here. Copy, and I'll paste it here, okay? Cronbach's alpha equals 0.706. Coefficient alpha is generally considered good if the scale reliability is 0.70 or greater, and we have a citation. Okay. That's the first thing you're going to do to analyze your scale. We want to know if it's a good, well, not a scale, but a survey. We want to know if it's a good survey. Is it a reliable survey? Is it valid, right? You want to save all of your notes when you're doing your statistics in order to know what you've done so far, okay? All right, once you get to 0.70 or greater, stop. Don't keep removing items to get higher reliability. That's not the way it works. And remember, only remove one item at a time, okay? You saw how we did it painstakingly with one item at a time. We wrote down what the new reliability was. We removed the next item until we got up to 0.70. Okay, that's the proper way to do the analysis. Now let's go back. Let's say that our hypothesis was that younger children might score lower on this survey for some reason. I don't know, okay? That's just coming off the top of my head. But, you know, when you're doing your survey, you need to figure out, well, would younger children score lower or higher on this survey and why? You should have that all worked out in advance, right? Now, how do we figure that out? What we're going to do is get an overall score for adaptive items, an overall score for protective items, and an overall score for risk items. That's the first thing I'm going to do. So I'm going to go back to my email and grab this Excel spreadsheet again and open it up. Oh, it opened up down here. Okay. Now, how do I do that? I'm going to go over here to the very end of the survey, and I'm just going to go all the way to the top. All right. I'm going to call this one adaptive score. And then the next one is going to be protective score. The next one, the next column will be called risk score. Okay, there are three types of items on the scale, right? And then I'm going to say overall score. Okay, so we're going to get some scores for each one of these, and they're going to be summed. How do I do that? Okay, here for the first participant, I'm going to go equals on my keyboard. And then I'm going to go back to all the adaptive items and add them up. So how do I do that? I'm going to go sum, and then I'm going to pull this down. Do you see where I got that? It was right up here, and I click sum. Okay, for all the adaptive items, I'm just going to click on these and hit a comma. Click on that one, hit a comma. Click on that one, hit a comma. For all the adaptive items, I'm going to do that. Okay, I've got to move over. Here's one. All right, so again, I've gotten the last adaptive item, and now I'm going to click OK. So the score for that first participant on adaptive items is 37. Okay, I'm going to do the same thing for each of these other two planks. I'm going to go equals, sum, move this down. I'll go all the way to the beginning again of the scale. I'm going to find all the protective items. So I'm going to click on this one since it's protective and comma. What's the next protective? Here, comma, here, comma, here. Let me keep moving across. So every time you click in a cell, you hit comma and go to the next one. All the protection items. Okay. Got to move over here. There's no more. Okay. So I did AC2 as the last one. All right, that's correct. And then I'm going to click OK. Okay, now let me move over and we have to do risk score. I'm going to click equals in this first cell, sum, and now I need all the risk items. So I'll click on risk here, comma, risk here, comma, and go through and do all of those risk items. And that's it. Okay, I don't need a comma for that last one. And I'll click OK. Now, you know what I forgot to do is remove those items that were not reliable. Do we remember which items were not reliable? I don't, because I closed out my notes. Oh no. So what do? I'll have to just leave them in for this lecture, but you make sure that you remove the items that weren't any good on the original scale because they weren't reliable. Okay? That's a mistake that I made because I closed out my notes. All right, now we need an overall scale score for the whole survey. I'm going to go equals sum. I'll go all the way back to item 1. I'm just going to highlight all of these scores for the first person, the first child in the study, all the way to 39, and click OK. All right. Now, you see, all I have to do to get these scores for every participant, I don't have to do it for each participant. No. All I have to do is highlight these that I've already done for the first child. I'm going to grab this corner. Do you see that little box here in the very corner, the green box? I'm going to grab that and pull it down all the way to number 232 child. I think I went too far. And you're going to see magically that all of the scores are calculated for all of the participants. Okay? Do you see that? Now I'm going to put these 4 columns in Excel. So I'll go back to variable view, and I'm going to call this adaptive score. I'll call this one what's it called? Protective, right? Protective score. And the next one will be called risk score, right? And then overall score. So I've added 4 variable names here. I'll go back to data view, and see these are all labeled now, aren't they? Go back to Excel. I'm going to copy all of these numbers for these 4 items, and I'll click paste. Okay, let's make sure everything is in here. And they are. Good. All right, now in my results section, what I'm going to say is younger and older children in the study were organized into, and what were the ages? Let me go back over here in my spreadsheet. Ages 9 and 10 and 11 and 12. Ages 9 and 10, younger children group, and was it 11 and 12? 11 and 12, older children group. That variable, age group, was entered into and I'm going to tell you the name of the test that we can use, since we only have 2 different groups, and they're independent groups because, you know, nobody can fit into both groups. A child can only fit into one and only one group. We're going to call this an independent samples t-test with adaptability, I'm not spelling too good right now, adaptability risk, protective, and overall survey scores. Okay, results showed, and then we're going to figure out the results. Now, t-tests, the T is always italicized, okay? All right, am I going too fast? You're going to figure all this out just by taking notes, okay? But what I'm going to do, I'm going to click Analyze. We're going to be comparing means this time in an independent samples t-test. Age is going to be our grouping variable or our independent variable. I'm going to click this box for that. Notice we have 2 question marks here. We want to know what are the dummy codes for the age groups. So we click on Define Groups. The younger children are dummy coded group 1. The older children are group 2. Okay? So that's the way you kind of set in the dummy codes so you can do this test. Then I'll click Continue. Now we need those 4 items. The adaptive score, I'll click in the test variable. Protective score, test variable. Risk score, test variable. And overall score there. Okay? Now, I don't think there are any options that I need to worry about. I'll hit Cancel. And I'm just going to click OK, and let's see what the results are and how to interpret those, okay? All right, the first thing that psychologists usually do is we look at this box right here. It's called significance level, okay? If 2 means or averages, if 2 averages on some survey are significantly different, you'll find that the significance level is 0.05 or less. Okay? Let's go down this column, the significance column, and let's say yes or no. Are these means significantly different? Well, for adaptive scores, no. I'm going to say no. For protective scores, no. For risk scores, yes, because this is 0.05 or lower, right? And so we can say that this t-test says that for the risk scores, the risk means, the younger children had lower average scores on these risk factors that are in the scale, and older children had higher risk factors in the scale. And that tells us something, doesn't it? I don't know how these students define risk, but it does mean that older children are riskier during the pandemic than younger children. Do you see that just in the numbers? All right, so the reports on that risk scale show that the older kids are being more risky than the younger kids. And that's an important finding, isn't it? That is an important finding. We go down the column, and was the overall score significantly different? No, it's not even close. It's not even close to 0.05 or below. Do you see that? In your notes, write 0.05 or below tells me that 2 averages are significantly different. Okay? Keep that in your notes, and you'll be able to understand how to interpret these tests. Okay? This is actually the candy that psychologists look for in a results, in an analysis. It's really cool. You get to the end and you are just hoping and praying that you're going to get at least one item that's going to be 0.05 or less. Now, if all of these were above 0.05, oh my, we did this whole study and didn't find anything. Do you see that? But it's cool that we did find at least one thing that was different between younger and older kids. And that's exciting, isn't it? And it tells us something psychologically. What happens during the pandemic? Well, the older kids who are 11 and 12 are taking more risks than the younger kids who are 9 and 10. Okay? And that's what we can write up in our discussion. Now, let's finish writing our results section before we jump ahead to something else. Okay. Now, I can't see this stuff. I'll just kind of move it over a bit. Well, I can't see what's going on there either. Results showed that only risk items on the survey were higher for older children, and then in parentheses I'm going to put the mean and standard deviation for the risk scores. 47.78 is the mean, and the standard deviation is 4.74. Okay, and now I'm going to put in the mean and standard deviation items here. The letters that tell us this is mean, this is standard deviation. You see how I did that? All of these items that are statistically concerned, you want to italicize, okay? All right, so results showed that only risk scores, let's just say scores, right, on the survey were higher for older children than younger children, and then I'll put their mean and standard deviation in parentheses. So for the young kids, oh, I put the younger kids in here. I'm sorry. I'm making a lot of mistakes today. All right, let me cut that. I'll put it here because that's the younger kids' scores. And the older kids were, mean is equal to 49.58 if you round it up. 49.58 standard deviation is equal to 4.52. 4.52. Okay. I noticed I have this wrong too. All right. So here I'm going to italicize mean and standard deviation. Now let's just check this to make sure I've got everything right. For the older kids, the average risk score was 49.58. Yeah, that's right. And standard deviation was 4.52 if you round it, okay? We rounded 2 decimal places, okay? And then for the younger kids, it's 47.78, that's what I have, and 4.74 for standard deviation. Good. And now we have to give the results of the test for the risk scores. How do we do that? All right. Let me move this up a bit. Can I make this smaller or something like, yeah, there we go. And now I'll pull it up. Oh, not that much. I'm sorry. Okay. And I'm just going to make it so it's on the upper half so I can look at the independent samples t-test results here. I'm going to put a comma here. I'm going to put T. Now we're looking at the t-value for the risk score test. The t-value for the risk score test is T, and then in degrees of freedom, we're going to put that in parentheses without any kind of space between T and degrees of freedom. And then what is the t-value? I'll go to the T column, and it's negative 2.94. 2.94, okay? And then we have to put the significance value. The exact significance value is P is equal to 0.004. And that's the way you write up results. Isn't that interesting? For a t-test. All right, let me pull that down. You see, this is an independent samples t-test. It is a t-test, so we disregard this F stuff over here, which gives us no meaningful results, and we just look at T. We look at degrees of freedom, and we look at the significance level, the p-value, okay? We call significance P in psychology, all right? So, these were cool results. We didn't find any results for adaptive items. We didn't find any results for protective items, but we did find something at least on risk scores. So you see that your survey results section is going to be something like this. You're going to see a couple of paragraphs. Now, one more thing before we quit. I just want to talk about what else can we do with scale results. Well, we can see if anything is correlated. In other words, and remember when I talked about correlation studies, if anything is correlated with these survey items, okay? Let me go back to the original spreadsheet. Now, they had some other demographic items. They had gender. Would it be important to see if being a male correlated with higher risk scores, for example, or being a girl correlated with lower risk scores or something like that? Well, we could look at that. So let's grab this gender variable and stick it in our SPSS spreadsheet. Let me just copy all those numbers. Copy. 1 is girl, 2 is boy. All right, I'm going to go gender, and I'll go over to the values box because we have to dummy code them, right? 1 is girl, add. 2 is boy, add. Now click OK. I'll go back to my spreadsheet here. All the way at the end you see gender, and then I'm going to paste the values there, okay? Why is there a 3 in here? Is there a gender that's 3 somewhere? I think that's a mistake in their spreadsheet, isn't it? Now, we don't really know, just looking at this, and we can't really ask the students from way back when to tell us if this 3 is a boy or a girl. There are a couple 3s here, right? There's one here. I'm going to delete those 3s because we don't know one way or the other if they were boys or girls, okay? So we'll leave those out. Were there any other 3s in this column? I think somebody just was typing wrong when they entered those data. Remember, enter your data perfectly and have somebody check you, okay? That's important. All right, so gender might be interesting. We already looked at age to see that it had an effect on risk scores between younger and older children. So I'm not going to include that in a correlation. Do kids have access to the internet? Is that important to what's on this survey? Do kids have access to the internet? If I don't have access to the internet, might I show a higher risk score than kids who do have access to the internet? I guess we could, so I'll go ahead and copy this column of numbers. Oops, wait, I have to go all the way to the top. Sorry. I'll go all the way to number 1. I'll grab all these numbers. Looks like a lot of kids have access to the internet, but there are some who don't. All right, I'm going to copy this column. And I'll go to SPSS, I'll go to variable view, internet access, all one word, okay? And 1 is yes and 2 is no. 1 is has internet, and I'll click add. and 2 is does not have internet. And I'll click add there. Okay. Click OK. Go back to data view and paste the dummy codes. Okay. Dummy codes. It's a good name for numbers that have no meaning. All right. Anything else in this spreadsheet? How many people are in the home? If we have a lot of people in the home, would that relate to being adaptive during the pandemic or protective or at risk during a pandemic? Let's see. You know, just think psychologically, does that have some kind of impact? If you have more people in a home during the pandemic, would older children have less supervision and maybe show more risk factors than the younger kids? I don't know. You know, we're kind of conflating two variables there when we think about age group and how many people are in the home, right? I don't know. I guess we're going to grab this and we'll just see if there's a relationship between the number of people in the house and in some scores that you have on this survey. I'll copy that. I'm going to call this one variable view people in home. Okay, and then I'm going to dummy code them. And it seems like one was what? One is 3 and under. 3 people and under. 3 people or less, add. Number 2 is 4 to 6 people. 4 to 6 people, add. And then number 3 is 7 or more people. 7 or more people, add. All right, I'll click OK. And then I'll paste in the numbers here, the dummy numbers. The dummy numbers. Okay, there they are. Now, what are we going to do? We're going to do a big correlation to see if any of these items relate. Okay, I have correlate by variate. That's the one you're going to choose. I think age is important. We'll look at it again. I'm just going to take the overall scores on adaptive, protective, risk, and overall score. And then I'm going to add in gender, internet access, and people in the home. So that's not many variables, but at least we can get a good idea of what variables relate. All right, I'll click OK. All right, now this is kind of a small table. Let's just look at it and see what it says to us. All right, age has no significant relationship to adaptive score. We know that because we ran that independent samples t-test, right? Protective score has no relationship to age, but risk score does, and that's the same significance score we got in that independent samples t-test, right? Okay, so that's all we're going to get for this. Okay, age has no relationship to gender or internet access or people in the home. You see the SIGs, right? So age and gender has no relationship. Age and internet access has no relationship, and age and people, the number of people in the home has no relationship, have no relationship. Let's go over here to gender, the gender column. Does gender relate to anything at all? Let's look at the SIGs. Okay, I don't see a 0.05 or less here anywhere. Do you? No. Gender has nothing to do with anything in this table. Okay, so that's Not interesting, is it? Internet access. Let's look at that. Internet access has a relationship, a very strong relationship, to adaptive score on the scale. So this is something I'm going to put in my results section. That's interesting, isn't it? All right, a correlation was conducted with the variables age, gender, internet access, and what's the other one? People in home, and number of people in home. How's that? And number of people in the home correlated with overall, well, let's see, it'd be adaptability, all these scores here. I'm just going to copy these and stick them down here, okay? So adaptability, risk, protective, and overall survey scores. Let me paste that here. Okay. Results showed a significant correlation between, was it internet access or people in home? What does it say? What did we find? It was, yeah, internet access and adaptive score. Internet access and adaptive score. And now a correlation is shown as R. How many? 232, right? There's 232 people in this test, so I'm going to put R232 is equal to, and then I have to put the R value, which is the correlation coefficient, and that is negative 0.239. Negative 0.239, and then the p-value is, seems like it was all zeros, right? Yeah. You see sig, I go over here, it's 0.000. Okay, p is equal to 0.000, but whenever SPSS shows that, you always add a 1 to the end of that, okay? That's because there's always a chance you have some error in the calculation. I'm going to italicize R and italicize P. All right, do you see how it worked? Okay, we have a negative relationship between internet access and this adaptation score. Why is that? Internet access was coded as 1 equals I have internet, is that right? And 2 equals I do not have internet. So what does that tell you? If I don't have internet, it means I have a lower adaptive score, whatever adaptation means in this study, okay? But we can talk about that in the results section. Let's continue because I'm taking too much time here. Here's another significant relationship between internet access and protective score. That's interesting, isn't it? Okay, so there was also a significant correlation between internet access and protective score, and that's R. Let's look it up. R232 equals negative 0.198. Okay, 232 equals negative 0.198. P-value was what? .002 for that one, okay? All right, so this is interesting. You have to think about these. It's negative because if you have internet, that's the lower number, and if you don't have internet, that's the higher number. And then you think about, is it the lower or higher score that correlates with not having internet? Well, you'll have to figure that out in your mind, right? And interpret these things. Now, you just continue through the output. I can see other ones. There's a significant score between risk score and internet access as well, and that is positive, which means, what does that mean? It means that you take more risks if you don't have internet access. That's what that means, okay? That's an interesting finding, isn't it? It doesn't say that internet access causes higher risk scores, right? But it does tell you that if you don't have internet in the home, you take more risks, okay? So you'll go ahead and add that to your results section. There's more here. Overall score is negative. That's significant because it's .05 or below. All right, here's another one. Nope, that's not it. There's nothing more in that. Okay. So internet access has a lot to do with lots of different things on this survey. Okay, and you have to interpret that. People in the home, does that relate to anything? Let's just quickly go through this. I don't see any significant relationships between that. It doesn't matter how many people you have in your home on this, as it relates to this survey, okay? So you can kind of just let that go, all right? Okay, I will continue. Now this is what you do with scales. I will continue this lecture in a second lecture. I know this was long, but I'm going to talk about experiments next, okay? So make sure you've taken lots of notes on the survey research and then take lots of notes on the experiment lecture next, okay? All right, so thank you very much.